Okay, quick introduction here to electric circuits. So if you're not familiar, a circuit is a continuous loop. Okay, that's really important, a continuous loop. So it can't be broken anywhere, all right? Consisting of an energy source, conducting wires. They're going to connect the energy source to one or more loads, and then a switch. Now, the switch can be open or closed. We'll have a look at what that looks like. When the switch is closed, then the loop is continuous. Okay, so you're going to need to be able to build a circuit, and I've taken photos of the circuit components that we have, and I'm indicating what they're called, what their symbols are, and what their function is in the circuit. So batteries here are operating as our energy source, and we use this long and short these vertical long and short lines to indicate the battery. So one line, one long and one short is a cell. I have 3 cells together here to form a battery. Essentially, I'd be happy if you're drawing a long and a short. Any number of those is fine for your energy source. Okay, connecting wires, we have red and black. They will connect the energy source and the loads that we'll be using, as well as our switches, and you can represent those with a straight line. Closed dots are at the end of that. Next, we have our light bulb. So here you can see this is the bulb here, and there's 2 terminals here where you plug in, you insert the end of these leads into each of these holes here. You'll notice that they are rubber on the outside and insulating material, and then metal on the inside. Same with the wires, they are rubber on the outside with a metal here, and it is a metal wire inside this rubber coating. So when you insert this prong into here, the metal contacts the metal inside, and that's what we need, metal contacting metal to move for electrons to flow around the circuit. Symbol for this light bulb is a circle with this curly Q kind of shape. All right, these are what our switches look like, and this is the top view. So I took this photo just with the switch resting on the desk. Again, you'll see the 2 points where you'll be plugging in, and a second wire here. Now I took a couple of side views. I'm not sure how well you can see this, but this switch is definitely open. So there's like a top and a bottom here, and there's definitely a gap in here. Okay, definitely a gap. We use that symbol, we use the symbol to show the open switch. So open circles here, right? And then this line is up, so you'll notice the gap, which means the switch is open. So the current cannot flow, the circuit is not closed when the switch is in the open position. Now here I'm pressing down, and you can see the point of contact that these 2 metal pieces are now touching. And so you have to press down to get this switch to stay closed. And now you can see that this lever has dropped down, and you have a closed switch. So here's your symbol for the closed switch. All right, now we have 2 measuring tools here. One is an ammeter. It's going to measure, one is an ammeter. It's going to measure the current for us in amperes, and the symbol for the amperes is A. So these are the units. So when you'll notice here there's a negative, so one of the wires will plug here, and then for most of our work you can plug into the 500 here. So the current that we have flowing is, we're reading the scale from the 0 to 500. So if the needle were to end up being over here, right, then you would read that as 400, in this case, milliamps. So again, it depends, but your plug, your wires here and here. The symbol you'll see in the circuit diagram is an A in a circle, capital A. A voltmeter, on the other hand, measures potential difference, so the voltage drop across a load or an energy source. So I'll show you later on how we connect that, but here's the symbol for it, V in a circle. So this is a voltmeter, and again, we'll have wire going here, and you have choices of 315 or 300 here. We're really looking at the 3, okay? The batteries that we're using, we're working really amongst the 3 volts. That's a better range. So we would be reading the middle scale of numbers here. Okay, so you'll see that this line here is 0, this line is 1, this line is 2, and this line up here is 3 volts. So if you've plugged your wire into one of these, then you have to read a different scale. But for us, we're going to plug into the 3, and so we'll be reading the middle set of numbers there. Okay, and that's where you are reading the voltage. Okay, so those are the components of the circuit, right? And the diagrams, the symbols that we use in the circuit diagrams. Okay, so in terms of drawing circuit diagrams, so that's what this heading is here, drawing circuit diagrams. I've got some circuits built, and I've drawn, or I've shown you what they look like with these photos. We're going to draw circuit diagrams beside each of these pictures. Okay, so we're going to use the symbols that we've already gone through, and if you want to think of, even though it may not look like a square or a rectangle, you want to build your circuit diagrams in squares or rectangles, okay? That'll be kind of the easiest way to do that. So, for example, I would tend to sketch a square here, okay? And the idea is that I would just erase the section where I then, so do these in pencil, where I then want to represent the battery. Now I need one little short there. So there we go. So there's the battery. Now the electrons are going to flow from the battery through the wire, right, to the load. You'll notice the light bulb's lit, right, because the circuit is closed. Metal's contacting metal all the way around. So I'm going to give myself a little gap here and draw this light bulb right at the bottom. Oops, not super there. I want to make sure that this line connects to the wire. Okay, it's important that you show that the metal parts, that there's connection all the way along so the circuit is closed. Okay, so we have an energy source, connecting wires, conducting wires, and a load. This load is the light bulb. So here's the energy source, here's our wires, and here's the load, the light bulb. Okay, so let's try the next one. And I'll just point out here that the light bulb isn't lit. So we have our energy source, we have our battery, right, with wires, and the light bulb is not lit. So what does that tell you about the switch? Hopefully you're thinking, yeah, the switch is open, right? I'd have to press it down to get the light bulb to light to close the circuit. So again, I'm going to start with this basic rectangle or square shape, and then I'm going to just erase in the middle here to be able to fit in the battery. And then if you took your finger and put your finger on the battery and then went and traced through the wire, you'd hit the load. So make sure from here that the next thing you have is the load. Now whether you want to put the load here or down here doesn't matter. Just make sure that the load, the light bulb, is the next symbol after the battery. So I'm going to put this here. Okay, so there's the load, the light bulb. And now after the light bulb, I want to keep tracing along the circuit, and I come to the switch. So maybe the switch looks to you like it's down here, or maybe it looks like it's up here. It really doesn't matter. It just needs to be next in line. So here, and I have an open switch, right? Because that light bulb's not lighting, so I know this must be an open switch. Okay, moving along. Have a look at this photo. You'll notice now that the light bulb is lit, and you see my finger pressing down on the switch, so you can tell that the switch is closed. So go ahead and use your symbols and try to draw a circuit diagram. Pause the video and check back when you're done. Okay, so you see my battery, right, with the load, the light bulb, and then now I have a closed switch. How do you know this is a switch? Because these circles are open. Okay, remember the circles need to be open for the switch. Alrighty. Here, I now have introduced an ammeter. Okay, so now you're drawing a circuit diagram where you have the battery, ammeter, light bulb, and switch. The light bulb is not lit, so make a decision about whether your switch is open or closed. You'll notice the needle on the ammeter is also not working or not showing, it's reading at 0. It would move this way if it was, if there was current flowing. So the current is not flowing right now, so that tells you something about the switch, right? And there are 2 clues that the current is not flowing. 1, the needle on the ammeter is over here at 0, and 2, the light bulb is not lit. So go ahead and draw your circuit, pause the video, draw your circuit, and then check back. Okay, so hopefully you decided the switch was open, right? And that's why the ammeter was reading at 0 right now, and the light bulb was not lit. But here we go. Energy source, right? Ammeter, load, which is our light bulb, open switch, back to the battery. So battery, ammeter, light bulb, switch, battery. So you can see that the symbols are in the same position as the components of the circuit in the photo. All right, now it looks similar, but we can see that the needle here has moved. The needle is reading here, okay, and the light bulb is glowing. So go ahead and draw the circuit diagram for this circuit. Pause the video and check back when you're done. Okay, I've just copied over this same diagram that I had before in the previous example, but now because the current is flowing, right, the light bulb is lit, we can tell that the switch is closed. So I'm going to show the switch to be closed. There we go. Okay, so this is the correct image for, or correct symbol for the closed switch. Alrighty, so any more there? No, that's it for those. Okay, so let's move on. And you did a gizmo the other day, so you've been exploring ways that you can connect multiple loads in the same circuit. You'll notice here that I have a battery and 2 light bulbs that are both glowing equally dim, right? They're not very bright. So whereas here I have a battery, it's really the same battery and the same 2 loads, same 2 light bulbs. The only difference is how I connected them. So try to draw your circuit diagrams, again, looking for rectangles or squares, okay? You'll notice here there's a path of electrons to flow from the battery to this load, and at this point the electrons can move across and come back to the battery, or they can, happens both ways. They come down here and come across and then make their way back to the battery. Whereas here, these electrons leave, come through this light bulb, and then they come to this light bulb, and then they head back to the battery. Okay, so draw both diagrams and see what you come up with. Pause the video and check back when you're done. Okay, so here we go. We have battery, light bulb, battery, which follows the same components: battery, light bulb, battery. Here we go, battery, light bulb to the battery. So battery, light bulb to the battery, then battery all the way down to the light bulb, right? And then all the way up. So battery all the way down to the light bulb and then all the way up. Okay. Now, there are certain terms that we use to describe the way that these bulbs are connected, right? We've already noticed that these ones are equally dim, right? Or equally less bright, right? And over here, we have both bulbs being lit equally bright. All right. What's the name then? And we'll talk in further detail about about these circuits, but for the purpose of this video and drawing circuit diagrams, we just want to be able to recognize, right, what we call this when the bulbs are connected in the same path. And you can see here the loads are connected in the same path. Hopefully you remember from your gizmo that those are called, it's a series circuit. Whereas over here, we call this a parallel circuit. So in a parallel circuit, you have multiple paths for the electrons to flow. And you'll notice the bulbs are equally bright. Okie dokie. So that's it for this one. Moving on. All right, here I have, actually we've already really done that, so that's your simple circuit. So here we have the battery with the ammeter and the bulb is lit, right? So this is a diagram you can draw. Give this one a shot. Pause the video, check back when you're done. Alrighty then, so we have the battery energy source, then the ammeter, which you can see is measuring the current. The needle's about here. And then we move on to the lit bulb, right? There was no switch in here, so as long as everything's connected metal to metal, we have the light bulb glowing because the current is flowing. Okay, last one here is a diagram that has both, a circuit that has both an ammeter and a voltmeter. So I'd purposely changed color of the wires. I'd like you to ignore right now the black wires in the voltmeter and just draw this piece. So just draw the battery, ammeter, and light bulb. Okay, so go ahead and draw that piece, and then we're going to add on the voltmeter. So again, I look to draw this rectangular path, and I'm going to make some space here for these symbols. So first I've got the battery, then I've got the ammeter detecting the current flow, then I've got the bulb, the load. Okay, so now I want to add, so that's the red wired connected part. Now I want to add this voltmeter. Notice that the voltmeter is outside the circuit. The voltmeter is sitting outside the circuit. It is connecting to the load outside the circuit, or in parallel, you might say. So notice that we've hooked this, right? These are the black leads here, right here, and this is the voltmeter here. You can tell it's a voltmeter because it has a V, okay? And the needle is moved over here because it's reading the voltage. It's reading the voltage drop across the bulb. Electrons flow from negative to positive, and they are moving through the circuit here into that load, and then they continue and return back to the battery. So as these electrons move, right, when they leave the battery, they have a certain energy that was given to them by the chemical reaction happening in the battery. So there's a chemical potential energy there that's transformed into the energy of these moving electrons we call electrical energy. The ammeter picks up the flow. It detects the flow of electrons. So when this needle over here moves, right, from 0, and it looks like it's about here right now, it's indicating that's probably about 3 volts. Okay, as the current keeps flowing, the electrons flow, they come in with the energy they had when they left the battery. Okay, so the voltmeter is picking up the energy that they're coming in with. Then that energy is transformed from electrical energy to light energy, and maybe a little bit of heat too, a little bit of thermal energy if that bulb starts to feel warm. So that energy gets transformed, right, from electrical energy into the light energy predominantly, and in doing so, those electrons have lost energy. So when they come out on this side, we still have the same number of electrons, but now they don't have the same energy they had before. The voltmeter is picking up the difference. How much did the voltage drop? How much did the energy of the electron change from this point to this point? So there's really, in this circuit, 2 places where the energy of the electron changes. First of all, it chemical potential energy, right, transfers energy to these electrons in the battery. And so there's a difference between the electrons that are coming in here empty without energy, right, and when they leave the battery. So the chemical reaction has given the electrons energy. And now those electrons move with their high energy to the load through the ammeter to the load. There, that energy gets used by the light bulb to glow as light energy. And so the electrons leaving have much less energy, much lower energy, and they return to the battery, okay, where they will gain more energy. So the voltmeter is outside, right, measuring across the load. So we'll just make a quick note of that. Okay, so when you hook up the voltmeter, make sure you hook it up across the load, or you could have hooked it up across the battery here. So it's either the energy source or the load. That's where the energy of the electrons is changing. And when you do, hook it up outside the circuit. So don't put it in the middle of the circuit. Don't, separate this and insert it in here, right? Make sure it's outside the circuit, or really in parallel, right? So do you see how this is similar to the parallel arrangement of the light bulbs we had in our parallel circuit? So hook up the voltmeter outside the circuit. All right, so in class, we're going to work with these components. You need to be able to build a circuit given a circuit diagram. You need to be able to draw a circuit diagram given a description of the circuit in words, and then be able to build that circuit. Okay, so we'll work at building these circuits and interpreting the diagrams in class.